Lab 19.
Yep.
19, and the title of that lab is exonuclease, which is the exoenzyme. That's the name of it. For breaking down what, do you think? Nucleic acids. That's our only macromolecule left, right? We've done starch, which is a carbohydrate. We did protein. We did fat. Nucleic acid hydrolysis is what we're testing here. Last macromolecule. The name of the enzyme here is not just nuclease. You do have to be specific with this and put the exo onto the name of the exoenzyme. That's to distinguish it from what you learned in Chapter 8 lecture, endonuclease. Remember that? Those repair mechanisms for checking behind DNA polymerase. Okay, this is a different molecule, so you've got to have the exo in there to separate it from endo. Again, this one's secreted right to the outside of the cell. Nucleic acid hydrolysis is going to be done externally. So we're going to give them a source of nucleic acid, DNA. We're going to use a different auger than the one in your lab book. If you were to memorize the one in your lab book, I would give you credit for it, but ours is easier to spell, so I'm sure you're going to go with ours. The one that we use is just called DNase auger. But that's just the brand name. DNase is not the exoenzyme. Okay, that's just the name of the auger. The exoenzyme is exonuclease, so don't get tricked by that. Okay. This is a real pretty green one. They put methyl green into the mix. That's the green color. They basically stained the DNA green. There's DNA in here. Methyl green is already in it. That's 2 words. Yeah, methyl green's 2. Let's see. You do have 3 bacteria for this test. So for this one, you want to draw a T and divide your plate into 4 sections, so that you still have 1 for control, and then you've got 3 bacteria that you'll label, right, which one you're putting where. Same process here, aseptic technique, flame your loop, the opening of the tubes, draw 1 small straight line of each of those 3 bacteria in their section, leave 4 for control. Whichever bacteria is positive, let's assume it's 3, it's going to produce exonuclease and destroy all of the DNA around it. With this particular test, that also destroys the green color. So when we come back next time, there's no need to add a reagent because it's already green. Positive result, there'll be no green color around the bacterial growth. The bacteria will have released exonuclease and destroyed it all. So no green color around the bacterial growth. And any negative bacteria, what are they going to look like?
Green.
It has green color around the growth. And what does that mean? Did not produce exonuclease. Okay. And that one's on page 68 of your photographic atlas, the exonuclease test, page 68 of the photographic atlas. So what labs are on your quiz on Wednesday?
15, 16, 17, 19.
15, 16, 17, and 19. The 17 has 2 sets of information in it. So remember, for all of them, you want to know the reason we're doing it, right? See if they produce casease or not. See if they produce exonuclease or not. The name of the auger that we use.
Right.
Any reagents that we have to add, if there is one. Right? What positive and negative look like, what positive and negative mean. And as always, read through the introductions, any bold words that are in here, potentially quizzable as well. Questions? Okay, if you could bring me your 2 old plates when you come up to collect your new stuff, and go ahead and get started.